Now we'll turn our attention to the quotient of two functions. All right, so how do I take the derivative of the quotient of two functions? We saw again that if h of x was, if f of x was x and g of x was x, then we couldn't just take the derivative of the numerator and denominator, because their quotient would be 1, and so its derivative is 0. But if I took the derivative individually, I'd get 1 over 1, which is 1. We saw this in an earlier video. All right. We could, and your book goes back to the definition of the derivative to do this, but the quotient rule, as I see it, is actually a result of the product rule. So what I will do is I'll use the product rule to find a formula for the quotient rule. Let's start by multiplying. I'm going to start with the function h of x is equal to f of x over g of x, and my goal is to find h prime, to find the derivative of this quotient. I'm going to start by taking h of x equals f of x over g of x and multiplying both sides by g of x to clear the denominator. Okay, on the left side I'll have g of x times h of x, and on the right side I'll just have f of x. Now let's take the derivative of each side. If I take the derivative of the left side, since the left side is a product of two functions, I'll make two copies. And on the right side, of course, I'll just have the derivative of f. In the first copy here, I'll take the derivative of the first function, g of x. In the second copy, I'll take the derivative of the second one, and then I'll add them. So notice what I get. Remember, we're trying to find out what h prime of x is, so I'm trying to solve for this, for h prime of x. So let's start by subtracting g prime of x times h of x from both sides. And if I do that, I'll have g of x times h prime of x is equal to f prime of x minus g prime of x times h of x. Now remember, h of x was f of x divided by g of x, so we have that g of x times h prime of x is equal to f prime of x minus g prime of x times h of x, times f of x over g of x. I'm going to combine these two expressions, so I'll need a common denominator. I'm going to multiply this by g of x over g of x. And when we do that, we get the result that g of x times h prime of x is equal to f prime of x times g of x minus f of x times g prime of x all over g of x, that common denominator. If you look at this, the numerator looks a lot like the product rule, except for this subtraction symbol. We have to be careful of that. That's very important. Then h prime of x dividing by g of x, h prime of x is going to be f prime of x times g of x minus f of x times g prime of x all over, if I divide both sides by g of x, I'll have g of x squared in the denominator, so divided by g of x squared. So remember, h of x was f of x over g of x, so this leads us to that the derivative with respect to x of f of x over g of x is the derivative of f with respect to x times g of x, the derivative of the first times the second, minus the first f of x times the derivative of the second, derivative of g of x, all divided by g of x squared. Okay? Now keep in mind here that if we look at this, there's not really a first function and a last function. There's a numerator function and the denominator function. We have to be very, very careful here because we're subtracting. If we would mix these terms up, then we would get the wrong answer because subtraction isn't commutative. So keep in mind that we have to take the derivative of the numerator in the first term and leave the denominator alone and take the derivative of the denominator in the second term.